In data center applications, which tasks DPUs are good at but cannot be done on CPU, GPU, or their complex?
First of all, I really think that we should put GPUs aside because they are really a different type of architecture, a different type of accelerator that is used for very specific type of tasks that are really, really compute intensive. Second, and also really important, it's we always need to ask when we talk about good at, right? So for example, if you are a cloud vendor and you pay for x86 cores to Intel, but build SmartNICs or DPUs with ARMs yourself, offloading tasks to ARMs would be much, much cheaper from the COPEX perspective, right? So it's not about performance even, it's about the cost. You can do more for much less because you would be able to free the x86 cores that would be much more expensive to provide. Similarly, if you're a public cloud vendor and you need to implement a network virtualization, you're going to prefer to run the associated processing on external DPU cores, as the virtualization is rightly considered a pure overhead from the cloud perspective. So instead of wasting x86 cores on it, you would really put it on DPUs and you would sell the x86 cores for more, right? So that's what, for example, Amazon Nitro cards do. They really take away most of the overhead of a network and the virtualization processing. So the net effect is that some data is processed far from the CPU and never even gets into the host. So you reduce the amount of I/O. But let's make it very clear. While the use of DPUs helps free x86 cores, it does not necessarily bring something that cannot be effectively implemented with x86 cores from the beginning. In other words, in my view, and this is my personal opinion, a DPU is there to free x86 cores and potentially take advantage of a few hardware accelerators that can be tightly integrated with the DPU by the vendors without being dependent on CPU vendors that much. It's much less of a special purpose processor that implements some really high performance offloads like GPUs that can run some workloads 10x faster than CPU. As a matter of fact, single ARM core on a NIC is about 1/3 or to 1/5 of a capabilities of a x86. So you can imagine that you cannot really beat x86 in terms of performance, but you can in terms of the cost.
So that sounds like a promising future. But what challenges does DPU face in terms of algorithm and hardware?
Architecturally, as I said, DPUs are weaker than a CPU, than x86 CPU core. The DPU processing is not as strong. And this is by design. There's no free lunch kind of. A SmartNIC, a DPU, consumes much less power than an x86 core. Just to give you an idea, a single DPU with all of its logic is about 30 watt of power. A GPU is between 250 to 300, a powerful GPU. And a CPU with all of its cores, a single chip, its single die is between 80 to 120 to 150. So you can see that this is substantially lower power envelope. And the outcome is apparently lower computational capabilities. So one needs to really figure out where you don't really need that much of a compute, and you can leverage the fact that it has very low latency to the network so that you can perform a bunch of processing without going to all the way over PCI to the CPU. Second, a DPU is usually used to perform some processing of the incoming traffic. For example, one can imagine it should be easy to offload something like TLS termination. That is when I'm running a HTTP server or a client on a host, mostly for servers, that's what's interesting. And I would like to make sure that the connection is secure. But there's a catch. So on the surface, it seems that this would be perfect offload for the SmartNIC. However, TLS termination implies that you would also have to run the whole TCP stack on the DPU, because network stack is layered, right? You have multiple layers where one depends on the other. And so you cannot just, take the whole network processing pipeline and then grab one stage in the middle, perform it on the DPU, and all the rest perform the CPU. You would pay a huge cost of back and forth. And so On the other hand, if you do need to push everything to the DPU, then you face this problem of slower processing if you don't have the appropriate hardware offloads for that. Last but not least, since the DPUs are not too strong, processing the whole traffic that is going in at the line rate is not a good idea. So you really need to have some smarties inside the ASIC, inside the NIC itself, that knows how to steer only part of the traffic into the DPU for processing, and all the rest should be going to the host directly.